What is up, guys? Welcome to another episode of CCT. So today we're going to be going over the 4-sum 2 problem, and yeah, let's jump right into it. This is a medium level problem, and I don't think it's too bad. I think it's very similar to another sum problem, which we'll get to in a minute. But I kind of forgot about the other sum problem, so it made this one harder for me. Anyway, the question's pretty simple. You have four vectors or lists or whatever, A, B, C, and D, and you have to, using one element from each one of the vectors, it has to sum to 0. And you're supposed to count how many ways you could sum to 0 using one element in each vector. Exactly one. So you can't have more, 2 in B and none from C. It has to be one from each of these lists. Furthermore, it is 4-sum, so you always are going to have 4 vectors. That you could be guaranteed. Alright, let's go to the drawing board. Whoops, that's not it. Okay, hold up. Mischief. Let's put that there. Let's get rid of, I don't really need this stuff. Yeah, wait, let me just quickly just fix this window. I only want, yeah, I don't need that. And yeah, that's fine. Okay. What color are we gonna pick today? Let's pick, yeah, whoa, that's really thin. Wait, well, let's do like blue, like that. Like that's cool how you could just drag it, right? Little thinner maybe. Let's figure out which one is it again. Let's zoom in, zoom out, brush size decrease. There we go. Nope, increase, decrease. Perfect. And this one's eraser, right. Alright, so whenever you want one element, whenever you're like trying to go through 4 lists, having one of each thing, whenever you're trying to go through a lot of things, the first thing that pops into my head is you could do lots of for loops, like going through A, what? Oh, like going through A, for loop, B, for loop, C, for loop, D, for loop. But what's the more elegant way of doing this for loop? The same time complexity, like this is what, n to the 4th? The more elegant way is you could do this recursively by having like one vector going to a for loop, and then it calls the function here again to do something. So let's actually do that way first. So drawing out, we want to go through all the vectors. So, and we want one of each element. So the first thing that popped into my head was we could visualize this as a tree, right? So like this is A's stuff, A's level. This is A and B's level. This is A, B, and C's level. And this is A, B, C, and D's level. Dot, dot, dot. Okay, right? Now this is looking even more like a recursive thing. Okay, so how could we write this? Recursively, we need to, what do we need to keep track of? We want to find the sum at the end of each of these. Like at each of these points, we want the sum, and if it equals 0, we want to increase our count, because we're looking for how many paths in this tree sum to 0. So what we could do is we could have, I'm not sure what goes in foo right now, but I know that we're going to be going through one of the vectors, so for I whatever 0 I is less than v dot length. Okay, and basically what the things that we want to keep track of, we're gonna need to keep track of the vector that we're on. So maybe we could have like an int row or something. And we're also going to want to keep track of the current sum. And we're also going to want to keep track of the count. Oh wait, I can't do that right now. Although we could store the count somewhere else. Right? So really, it's pretty simple what we do for when we're going through the for loop of, let's just pick, for example, like now we're in the bth row or something. So we're going through the b's vector, and we know that it's vector b because we have the row here, and we somehow figure that out. So then we make a call to foo with row plus 1, and then sum plus the b at I or something. And then this goes in here, and then it's going to be the next row, which will represent C, and then C will add its ith value, then it'll go here, and then it'll get to D. How do we know when to stop? Well, we know that there's only 4 rows, so how do I move things? Is this it? No. It's this. No. Wait. If I do that, hold up. Wait. Command X. Nope. Yeah, here. So I want to have a if condition here. So like, if row equals let's write 3 because on the third row we want it to stop. Then we check like if the sum equals 0, then we could increase the count because we've gotten to the end. And if not, I mean, we're at the end, so we're still going to want to just return. Now, I'm thinking about this. So if when the row equals 3, assuming we're doing zero-based indexing, I don't think we'd get to add the D's elements to the sum at this point. So I think we need to wait one more until this is 4. So it gets to here, and like the row's currently 3, and then it calls foo with +1. And when it calls foo with row +1, the sum has the D's elements in there. So yeah. Okay, so what does this accomplish? I'm not going into the details on how like you translate the row to the vector or whatever, but this is just the idea of a simple recursion to make this stuff faster. Or sorry, cleaner. Right now we have not made it faster. These have the same complexities because it's still going to have to go through all of these paths just like it would with our for loop up here. It didn't do that, but so we're doing it the recursive way is cleaner, but we could also add like pruning stuff a lot easier when we do recursion. So that's this. Like, I'm trying to take you through the path of how I thought about it, and at this point I was thinking, well, this is taking way too long. This is n to the 4th. I actually failed it on time. It's n to the 4th. It's just way too long. So I thought, is there any way to know as I'm going through this tree that like there's no way I could get to 0 from here? So if a, like this is like whatever, -5 and +4 from the b's, Is there any way to know at this point if I'm going to make it or not? I mean, you could only save so much. So I started to think maybe I could save like C until D, like kind of saving using dynamic memory, but I mean, there's just nothing really to save. You're going to have to go through the C's elements and D's elements to get there. And eventually I couldn't figure it out, and then I looked at the answers. And they had a very different way of approaching this. They had a way similar to if you ever did the regular sum. I think it was called like two sum or something, where they had only two vectors, so A, blah, 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 and B, and they would ask how many pairs of these sum to 0. And the way they did that was they kept all the values in A in a map, so map A, and so they went through it, put all of them in, that's time complexity O of n. And then what they did is they looked, that's not the best way of saying it. They went through B's elements, negated them, and saw if those elements were in A. Well, what does that do? If you negate the elements in B and you find them in A, that means that there's a negation in A that could sum with that B's element to be 0. Okay, so that's how you could do a count plus plus. And furthermore, what happens if A has like, let's say A has a 2 here and another 2 here, and B has a -2 somewhere here. This should count as 2 ways to get to 0, right? So maybe in the map, you can map the number 2 to its, well, let me write it like this. So number to its frequency. And then when you find its negation in B, you add to the count the frequency instead of just always 1. What happens if you find -2 again here? Well, you should probably do the same thing because these are 2 ways to get to 0. These also count as 2 ways to get to 0. So again, you have to add the frequency of 2, which happens to also point to 2 for A. This is like A's map. And so the count at this point would be 4, because you get 2 from this and 2 from this. How could we make this two-sum problem with vectors with 4 vectors? I'll tell you, you could do it in n squared time. So before it was n to the 4th, so before my way or whatever, going through all the values, it was n to the 4th. Now you could cut that time drastically. So what you can do is you can kind of combine these vectors and then treat them as 2 vectors. So we could have vector AB, which has all of the sums of all the elements in A and B. That would take n squared time to make that map. So we have map AB. And then we could go through all the sums of C and D, which would also take n squared, and see if we could find the negations on the other side. So basically, the only difference from the 2-sum and the 4-sum is the fact that we are combining 2 of these vectors by finding all the combinations of their sums, and that is essentially turning it into 1 vector. So again, if we have like 2 here, like some A and B elements sum to 2, fine. And then we had 2 here, and then we found some CD elements summed to -2. When we get to -2, the count here would be, so map AB would look something like the value 2 points to the frequency 2, and then if we found -2 by some summing of CD, then we could add the frequency to the count. Alright? Okay, let's get coding. Whoops. So, what we can start off by doing is, do we need the index? No, I don't think we do. So we could go for auto, and just for the record, I've never actually typed this up. I've seen some of the answers, but yeah. So we could go auto for loop A, and for auto B, B. So now we're getting into n squared territory. And, okay. How do you make a map? Okay, I probably should make unordered map. I should do a video about like when to use what data structures. I'm actually a little shaky on when to use map versus unordered map. I just know unordered maps use hashes, and they're better at some insertions or searches or something like that. So we have int for value, int for frequency, and let's call it AB. Cool. So now AB is at, so it's going to be A plus B, right? The sum, we're getting every combination of the sum, and yeah, we're just going to plus plus, like that. That's going to get the frequency of every combination of sums with A and B. Next, moving on. Now we're going to go through C stuff, and C, oh sorry, D now, right? And okay, yeah, so let's do count, int count equals 0. So count is going to plus equal, we want to get the frequency of the negation of C plus D, so that's a little trick to get the negation of C plus, or C and D. Yeah, so if the negation of the sum of this C and D is in A and B, then we could add all those frequencies to the count. Right, it's essentially going right back to this problem, which hopefully makes sense when there's two vectors, because we have essentially turned 4 vectors into 2 vectors by spending n squared time to compute all of the combinations between A, B, and between C, D. Okay, so yeah, and this also has the thing where the count is plus equaling the frequency, not just plus plus, right? Because there could be multiple ways to get to 2. I don't even know how it got to 2 here. It could have, yeah, it's some path from A to B got this one, another path got that one. Again, if you're thinking about it, that's how I'm kind of thinking about it in the tree. Some path from A to B got 2, maybe here, and some path here also got 2, right? So that's 2 ways, and then we could finish it off in the same way with the same CD pattern. Okay, so last thing, whoops, next line, return count. Let's run it, see what errors we made, fix them, and be done. Alright, I'm just going to submit that. It looks pretty good, I think. Alright, nice. Well, I hope you enjoyed this path of how I got to this answer / looked it up in the end, but I tried to walk you through my thought process. You learned a bit about recursion, and a bit about the best ways, or like when's a good use for maps, and a trick to get the four-sum problem to look a lot like the two-sum problem. Alright, I'll catch you next time. See ya!